Hello everyone, I am AK Kulkarni from Department of Electrical and Electronics Engineering. Let us start the course name called as Power Generation and Economics. Let us start. So we already previously studied in the class module 1 and module 2. So module 1 it mainly concentrate on the hydroelectric power station, and in module 2 we studied about the steam power plants and diesel power plants. But in module 3 we are going to concentrate on nuclear power plants. So let us see the contents of nuclear power plants. Okay, so this is the syllabus we are going to study in detail in this module. So as I told, so we are going to concentrate only on nuclear power plant in this module. So in this module we are going to study the brief introduction towards the nuclear power plant, how the economic aspects of the nuclear power plants, its merits and demerits. Okay, so after studying the brief introduction of the nuclear power plant, so further we'll go for the next section, that is selection of site for the nuclear power plant and the nuclear reaction which is going to take place inside the power plant. In detail we are going to study. So after that we are going to study the various parts which are present in the nuclear power plants, such as classification of the reactors, reactors and its uses. And after utilizing the nuclear energy from the particular element, so how you are going to dispose that nuclear material, so in detail we are going to study. Okay, so let us start with the introduction of nuclear power plant. So why nuclear power plants are necessary? As we know, there is a high demand for the electrical energy in the various sectors, as in industry. If you go to the your household, there is a high demand for the electrical energy, and which is increasing with the population. So we need to meet that electrical demand. So as we know, in our country the most of the electrical energy which is generated by means of steam power plants or with the help of hydroelectric power plants. And in case of steam power plants, as we know, the fossil fuels which are depleting day by day, such as oil and gases, so we need to look out for the other means of production of electricity. So for that reason the nuclear power plants comes into the picture. So in case of nuclear power plant, a huge amount of energy can be released from the small quantity of radioactive material. Okay, so with the help of small quantity of material we can produce high amount of energy in case of nuclear power plants, which is not possible in case of the various power plants, such as hydropower plants or in case of steam power plants. And but in case of nuclear power plant, the capital cost of the nuclear power plant is more, but the operating cost is much cheaper as compared to the remaining power plant. For example, let us consider two examples for this. Let us consider a power plant, Tarpura power plant, which supplies 40 paisa per kilowatt hour, and Kalpakam nuclear power station which supplies around 45. Now let us see what is a nuclear power station. It is nothing but it is a generating station in which nuclear energy is converted into electrical energy, and electrical energy is known as nuclear power station. In nuclear power station, the heavy elements such as uranium 235 or thorium 232 are subjected to the nuclear fission in a special apparatus known as a reactor. A heat energy thus released is utilized in raising the steam at high temperature and pressure. The steam runs the steam turbine, which converts steam energy into the mechanical energy. The turbine drives the alternator, which converts mechanical energy to the electrical energy. So the main ingredient, or you may call the main fuel we are going to use in nuclear power stations, are of two types. One is uranium-235 and thorium-232. With the help of these materials, we are going to convert the whatever the heat produced from these materials, we are going to convert into the steam energy with the help of the boilers. After converting the steam energy, we are going to drive the steam turbines with the help of converted steam energy, and in turn the turbine will be driving our generator. So in this way we are going to utilize the heat produced from these materials to convert electrical energy. So this conversion of heat to the electrical energy, it will take place inside the nuclear reactor. The bombardment will take place in the nuclear reactor. So due to this bombardment, the uranium 235 or thorium 232, it's split into two atoms. After splitting into two atoms, it releases the huge amount of energy, is known as nuclear reaction or nuclear fission. So the neutrons in the strike on uranium atom, or uranium atom splits into two components and huge amount of heat energy is released. So as I told before, when the bombardment takes place in the nuclear reactor, so it will split up into the two atoms, releasing the huge amount of energy. So we are going to use that huge amount of energy to heat the water which is present in the boiler and to produce the steam energy. So this mass defect is given by the Einstein's relation E is equal to mc square. So here we are going to use the generated heat energy, and thus released during that is released during the nuclear fusion, we are going to utilize to produce the steam at high temperature and pressure. So this generated steam, in turn we are going to run the steam turbines which convert the steam energy into the mechanical energy. The steam turbine drives the alternator which converts mechanical energy to what? Electrical energy. So as I explained before only, so what will happen in nuclear power station is, so when we are going to take two elements, so there are mainly two elements we can utilize, either uranium 235 or thorium 232. So with the help of these materials, what we are going to do, we are going to split the atoms of these materials into two atoms. So that is done inside the nuclear reactor. So once the atoms are splitted out, so it will produce high amount of energy, or high amount of energy will be liberated by separating these two atoms. So we are going to utilize that high amount of energy to to produce the steam with the help of the boilers. So once we produce the steam with the help of the boilers, which in turns we are going to drive the steam turbines which converts steam energy to the mechanical energy. As we know, steam turbine which is coupled to the alternator which converts the mechanical energy to what? Electrical energy. So in this way your entire nuclear power station works. The main advantage of a nuclear power station is that when the huge amount of energy is produced from relatively small amount of nuclear fuel as compared to the what conventional type of power station, such as your hydro, it may be a hydroelectric power station or it may be a steam power plant. In case of nuclear power station, what will happen, we are going to utilize the let us consider if we utilizing 1 kg of uranium 235, which is equivalent to what? The energy from 4500 tons of high grade coal. See how much less material we are going to utilize in case of nuclear power station, whereas compared to what? And steam powered station, where we are going to utilize around 4500 tons of the graded coal, whereas in case of nuclear power station we are going to utilize 1 kg of nuclear uranium 238 to produce same amount of energy. So let us see the merits and demerits of nuclear power plant. So let us begin with the merits of nuclear power plant. As we know, the amount of fuel requirement is very less as compared to what the other kind of resources. So the cost for the transportation of fuel and the storage is less. Nuclear power station requires less space as we are having less fuel to be stored. It is a low running charge. It has what? Low running charge, or a operating cost of the nuclear power plant is less. The small amount of fuel can produce what? Large electrical energy. So as I told, 1 kg of uranium 235 is equivalent to what? The energy produced of 4500 tons of coal. So for that reason, the amount of fuel can produce, very small amount of fuel can produce what? Large amount of electrical energy. So the output control is extreme feasible. So we can control the output, which is very flexible. Okay, this plant is very economical for producing large electrical power. So if the electrical energy demand is more, so for that reason we are going to utilize what kind of power station? Nuclear power stations. The cost of primary distribution is reduced. So as we are going to utilize very small amount of fuel, so the distribution is the cost of distribution will be reduced. The large deposit of nuclear fuels are available. As we know, the large deposit of nuclear fuels are available all over the world, so it can be ensured the continued supply of electrical energy for thousands of years as compared to the coal generated or coal powered power plants. And it emits low CO2, which means it is going to emit the carbon dioxide in lower level as compared to the steam powered plants. So now let us see the demerits of nuclear power plants. The fuel used, so whatever the fuel we are going to use is very expensive and it is very difficult to recover but as we know, the operating cost of the nuclear power plant is less, but the capital cost or the to manufacturing cost of the nuclear power plant is very high as compared to the other type of plants. And the erection of commissioning of the plant requires the technical knowledge. So it requires very technical knowledge engineers for the erection and commissioning of the entire plant. And as we know, the fusion reaction will be taking place, so after separating the atoms, so generally it is nothing but what? Radioactive elements, which is dangerous and for the human beings and as well as for the environment. So as we know, the maintenance charge, so the maintenance charge of the nuclear power plant is more due to the lack of standardization. Okay, so which means as we are aware of the complexity nature of such a plant, the maintenance charge will be more. And moreover, the nuclear power plants is not suited for the varying loads. So what does it mean is, if the loads which are connected to the nuclear power plants are varying, so such kind of loads cannot be connected to the nuclear power plants. So we want a stable load whose capacity of carrying the current will remain same throughout the function. So for that reason, the nuclear power plants are not suited for the varying loads. And moreover, the maintenance charge and the salary of maintenance employees are high. So as we are dealing with very hazardous material such as uranium 235 or thorium 232, the maintenance charge and the salary of such employees are very high as compared to the employees involved in the steam steam power plants or other conventional means of generating electrical energy. Okay, so after using the materials, so we need to suppose to dispose that byproducts. So those byproduct products are having a radioactive material. So those byproducts are nothing but your radioactive material, which is very big problem. We can't throw it outside the plant itself, so we need to bury it deep inside the sea. So which is more complexity as compared to the steam power plants. In steam power plants, we can store the ash in a storage area which is provided inside the plant itself. But in case of nuclear power plant, we need to dispose the radioactive material within the deep sea shores. Okay, and the cooling arrangement have to be required for the nuclear power plant. As been aware of, after splitting with the atoms, it will produce the huge amount of heat. So we need to contain that heat. For that reason, we require. Next topic is selection of site of nuclear power plant. So as we studied in steam generation power plant and hydroelectric power plants, we need to consider various aspects for installing such kind of power stations. Likewise, in nuclear power plants, we need to consider various aspects such as first one is availability of water. So we want sufficient water amount of required for cooling purpose and well as for heating the water purpose. So we need to look out for the availability of water. Next thing is disposal of waste. So this is a very important uh, point here, because in case of steam power plant we can dispose the ash in certain storages, but in case of nuclear stations it is not possible to throw the waste product anywhere, because it is a radioactive material. For that reason, we need to dispose such kind of radioactive material deep within the deep seashores. For that reason, we need to select the power plants which is situated near to the seashores or near to the some water available source. Then next point is the distance from populated area. It should be reasonable distance should be maintained from the populated area, because as we already aware of radioactive material, how hazardous it can be uh, to the environment as well as the human being. For that reason, it should be located located remotely, a remote area, because we need to maintain certain distance from the populated area. Next one is what? Transportation facility. So as we aware, we need certain fuel for operation of this entire nuclear power plant. So the transportation facility have to be made available either through the rail or through the road. Next one is nearness to the load center. Okay, so if possible, the nuclear power plants, if it is situated near to the some grid connected area or some other substation, we need to look out for a certain possibility. Okay, so these are the various points we need to consider before constructing the nuclear power plants. Okay, so let me recall what all the things we studied in today's class. So first, now what we studied is, so first we studied the various materials which you are going to use in nuclear power plants, such as fuels in nuclear power plants, such as uranium 235 or thorium 232. So after using these fuels, after which inside the nuclear reactor, so what will happen inside the nuclear reactor is, so we are going to make a bombardment in the nuclear reactor to separate the two atoms from these either of the materials. So once we separate the atoms from using from these materials, so after splitting the atoms, so it will generate huge amount of energy. So we are going to utilize this huge amount of energy to heat the water inside the boiler. So once we heat the water inside the boiler, so it will produces the steam. So we are going to utilize that produced steam to drive the steam turbines. So this steam turbine in turn, it will be coupled to the generator, so the generator will produce the electrical energy. So in this way, we are going to produce the electricity in the nuclear power plants. That's it for the day. So thank you.